So till now you have seen the different types of differential, the working of differential, and in the previous video you have seen the details about how the modeling of differential can be done, the parameters of the gears for modeling of gears, and the use of parameters or variables for global parameterization. So in this video we'll look at the motion study. So since this is a dynamic part of a automobile, so this is going to undergo some motion during the when the vehicle is in motion. So we need to do a motion study, so as to check that there are no interference between parts. When the parts are going to move, a part is not going to collide with other part. That's the purpose of checking the motion study. So now Ishan will say how the motion study is to be done.
So for the motion study, we already have defined the mates between all these gears, which define the radius of each gear to allow for a constant motion. So now we all need to do is attach a motor to one of these gears so that all the others can be driven accordingly. So this is the motor that we attached to this side gear, and we define the phase that it will act on, and then we define the RPM that it will rotate at. So after defining that, we click the green check mark, and we may allow it to calculate the motion using this button. And finally, this is what it gave us the output. And then we can also save this in a video, and this shows a much smoother motion.
Okay, great. So it means that there are no interference or there are no collision between parts. The entry and exit of the teeth with respect to two different gears are very smooth, and you have done a very great job of doing all the modeling and motion study. And the best part was the parameterization of the variables, so you can anytime change the values of those variables directly from the list available to you, and you have all the different gears, the size of gears, the number of tooth, and you are done with the newer assembly also. So great, done, great job. Thank you.